Good morning children, I am Poonam Bagga and we are studying chapter 3, Playing with Numbers. In our previous class we had learnt about factors and multiples, what are they and how to find them. Today we will be doing exercise 3.1 based on factors and multiples. The first question is, write all the factors of the following numbers. The first one is 24. Now what do you mean by a factor? A factor is a number that divides the given number completely, exactly, leaving no remainder, or the remainder should be 0. Here also we will be looking for numbers which divide 24 completely. We will be checking each number separately, 1, then 2, then 3, then 4, in such a way that we get numbers which divide 24 completely. So we start with the number 1. We know that every number is divided by 1. You can also check it by dividing 24 by 1. It's 1 2s are 2, 0, then 4, 1 4s are 4, again 0. So yes, 1 divides 24 completely and so 1 is a factor of 24. We also know that 1 is a factor of each number, every number, and also we know that every number is a factor of itself. So two factors are fixed. One is 1 and the other one is 24 itself. These two factors we already know now. So we have here 1 into 24, it's 24. Now we will check whether 2 divides 24 completely or not. 2 will divide 24 completely if 24 comes in the table of 2, or in other words, if 24 is a multiple of 2. So just think of it, is 24 present in the table of 2? Yes, we know that it's 2 12s are 24. Now 24 is a multiple of 2 also and 24 is a multiple of 12 also. Or in other words, if we will divide 24 by 2, then also the division will be exact, complete, with 0 as remainder, and if we divide 24 by 12, again we will get 0 as remainder. Let us do it also just for your checking. 24 divided by 2, it's 2 1s are 2, remainder 0, then 4 left, 2 2s are 4, remainder 0. Similarly, you can divide 24 by 12 also. It's 12 2s are 24, 0. So in both the cases we have 0 as the remainder. This means 2 divides 24 completely and 12 is also dividing 24 completely. So these two are the factors of 24. This is possible because 24 comes in the table of 2 also and 24 comes in the table of 12 also. Okay. So we have the other two factors, 2 and here 12. I am simultaneously writing the factors also, smaller ones to the left and greater ones to the right. Then we move on to the number 3. 3 will divide 24 completely if 24 comes in the table of 3. Is it there? Yes, we know 3 8s are 24. So we have the other two factors, 3 and 8. Okay, you can easily check by dividing 24 by 3 and by 8 also. Then we move on to the table of 4. Is 24 completely divisible by 4? Yes, it is, because 24 comes in the table of 4. It is 4 6 are 24. So 4 is again a factor of 24 and 6 is also a factor of 24. Then we move on to the table of 5. Is 24 present in the table of 5? No. A number ending with 0 or 5 is divisible by 5. Here we have 4 at the end. It is not divisible by 5, or 5 will not divide it completely. So 5 is not a factor of 24. Then we move on to the number 6. Is it present there in the table of 6? Yes, we know 6 4s are 24. But we have already taken the numbers 4 and 6. So here the numbers have started repeating and now we will stop here. And so we have all the factors in this way, 1, 2, 3, 4, 6, 8, 12, 24. In this U shape we take. And so we simply put a comma in between and we have all these factors of 24. Then we have the next one, find the factors of 15. Again we will start with the number 1. We know 1 is a factor of every number and we know every number is a factor of itself. So 1 and 15 are its two factors. Surely we know this. We can write 15 as 1 into 15. Then we move on to the table of 2. Is 2 dividing 15 completely? Will it divide it completely? You know that 2 8s is 16 and 2 7s is 14. So 15 is not there in the table of 2, or 15 is not a multiple of 2, and so 2 will not divide 15 completely. It is not a factor of 15. Then we move on to the table of 3. Will 3 divide 15 completely? Yes, we know 3 5s is 15. 15 is there in the table of 3 and so it will divide 15 completely. So 3 is a factor and yes, 5 is again a factor of 15. Then we move on to the number 4. Will 4 divide 15 completely? No, because 15 is not there in the table of 4. So 4 is not a factor of 15. Then we move on to 5. We know 5 3s are 15 and the numbers we have already taken 5 and 3. So we will not take it. These are the 4 factors of 15. 1, 3, 5 and 15. We will stop after the repetition starts. Then we have the next one, factors of 21. Again we have to find the numbers which divide 21 completely, and only those numbers will divide 21 completely in the table of which this 21 comes. So we know first 1 is a factor of every number and 21 is a factor of itself. It will be a factor of itself. Every number is a factor of itself. Then is 21 coming in table of 2? No. In table of 3? Yes, we know it's 3 7s are. Now I am trying to write the factors directly without applying the multiplication tables, writing them separately. I am writing them here directly. You also try to do this directly. So 3 7s are 21. Then we have the table of 4, 5 and 6. Is 21 there in the table of 4? No. In the table of 5 and 6? Again no. In the table of 7? Yes, 7 3s are, and we have already taken 7 and 3. So these are the 4 factors. The repetition has started when we take 7 3s are 21. So we will stop once the numbers start repeating, and we have these 4 numbers as the factors of 21. Then factors of 27. Here we have to find the factors of 27. For this we will be looking for numbers which divide 27 completely without leaving any remainder. We know 2 of its factors. We can write them straight away. The first one is 1 because 1 is a factor of every number, and also we know that every number is a factor of itself, and so the second factor we can write directly is 27, factor of itself. Now we need to find other factors, other numbers which divide 27 completely. We will be taking up each number separately. After 1, we will check for 2. Now 2 will divide 27 or not? 27 is not there in the table of 2. 2 13s is 26 and 2 14s is 28. So 2 will not divide it completely, and so 2 is not a factor of 27. Then we move on to the table of 3. Will 3 divide 27 completely? Yes, because 3 9s is 27 and therefore 3 will divide it, leaving a remainder 0. So 3 and 9 are 2 of its factors. Now what am I doing here is, I am writing the factors straight away directly without writing the multiplication statements as we were doing in the previous questions. You also try to write down all the factors directly in this way. Then we move on to the table of 4. Is 27 there in the table of 4? No. So 4 will not divide it completely. Is 27 there in the table of 5? No. Not in the table of 6, not in the table of 7, not in the table of 8. So all these numbers will not divide 27 completely. Then we move on to table of 9. Will 9 divide it completely? Yes, 9 3s is 27, but we have already taken 3 and 9. So again the numbers are repeating here, and we will stop here, and we have only these 4 factors for 27, 1, 3, 9 and 27. Okay, we move on to the next one. We have to write down the factors of 12. Again we know that 1 is a factor of every number and every number is a factor of itself. So these two factors are very well known to us. We can write it straight away, 1 into 12. Then we will look for 2. Will 2 divide 12 completely? Yes, because 2 6 is 12. So these two are the factors of 12. They will divide 12 completely. Then moving on to the table of 3. 3 4s is 12. Yes. And so 3 and 4 both will divide 12 completely. Then we move on to the table of 4. 4 3s are 12. Yes, but now you can see 3 and 4 we have already taken. So here the numbers have started repeating, and we will stop here, and these are the only factors of 12. Clear to you? We will be taking in this pattern 1, 2, 3, 4, 6, 12, taking in the U shape. Then write down the factors of 20. We now look for the factors of 20. We know that 1 is a factor of every number and 20 will be a factor of itself. So these two factors are very well known to us. Then we move on to 2. Will 2 divide 20 completely? Yes, because 20 comes in the table of 2. 2 tens is 20. So both 2 will divide it completely and 10 will also divide 20 completely. Then we move on to table of 3. Will 3 divide 20 completely? Obviously not, because 20 is not there in the table of 3, or 20 is not a multiple of 3. Then we move on to table of 4. Will 4 divide 20 completely? Yes, because it's 4 5s are 20. So both 5 and 4, they both will divide it completely, and so they are the factors of 20. Then we move on to the table of 5. 5 4s is again 20, and so 5 and 4 will divide 20, but these numbers we have already taken, and the numbers have started to repeat here, and so we will stop here, and we have all the factors of 20 as 1, then 2, then 4, 5, 10 and 20 in this way. Next we have 18. Again we have to look for numbers which divide 18 completely. Obviously 1 is its factor and 18 itself is a factor of 18. Then we move on to, will 2 divide 18 completely? Yes, we know it's 2 9s are 18, so it will divide. Then we move on to 3, it's 3 6 are 18, so 3 will again divide 18 and 6 also will divide it. Then we move on to the table of 4. Will 4 divide 18 completely? Is 18 there in the table of 4? No. So 4 is not a factor of 18. Is 5 a factor of 18? We know that a number ending with 0 and 5, only those numbers are divisible by 5. Here we have 8 at the end, at the ones place, so it will not be divided by 5, and 5 is not a factor of 18. Then we come to the table of 6. 6 3s is 18, but here we have taken 3 and 6 already, so the numbers again have started to repeat. We will stop here, and we have all the factors of 18 as 1, 2, 3, 6, 9 and 18. I hope you are getting all these points clearly. Then we move on to number 23. Obviously 1 is a factor of every number, and again 23 will be a factor of itself. Now we will look for numbers in which the table of which 23 will come, and those numbers will divide 23 completely. But can you think of any number in the table of which this 23 comes? You can think of 2. Is there 23? No. In the table of 3? Again no. In the table of 4, 5, 6, 7, 8, 9? None of these numbers have 23 in their table. So, these are the only two factors possible for 23. And so, factors of 23 are 1 and 23. Only two of them. Then we have number 36. This we have already discussed in the examples. Let us try to write down all those factors directly now. We know 1 is the first one and 36 will be the last one. And the remaining factors will lie between 1 and 36. We will be taking up each number separately. First we take up 2. Will 2 divide this 36 completely? Yes, we know. It's 2 18s are 36. So these are the two factors of 36 which will divide 36 completely with remainder 0. Then we move on to the table of 3. Will 3 divide it completely? Yes, we know. It's 3 12s are 36. So one of the factors will be 3 and the other one will be 12. Okay, so we are writing it directly here in this way without actually writing the multiplication statements. Then we move on to the table of 4. Will 4 divide 36 completely? Yes, because 36 comes in the table of 4. 4 9s are 36. We all know 4 and 9 will be its factors. Then we come to the number 5. Will 5 divide it completely? No, because we don't have a 0 or 5 at one's place. It's 6 here. So 5 will not divide it. Then 6. Is 36 there in the table of 6? Yes, we know it's 6 6 are 36. And here the numbers have started repeating also. 6 6 are. So 2 times 6. Repetition has started and so we will take 6 as its factor only once and we will stop here. And so these are all the factors of 36. Now we have the second question which says write first 5 multiples of 5. So we will write the table of 5 in fact. The first multiple of 5 will be 5 into 1 which is equal to 5. As you can see, then we will get the second multiple, multiplying 5 by 2, it's 10. Then we will get the third multiple by multiplying 5 by 3, it's 15. Fourth multiple we will get by multiplying 5 and 4 and this will be equal to 20, and then 5 into 5 will give us the fifth multiple which is 25. There are many more multiples of 5, but here we have been asked only first 5 multiples, and that's why we have taken 5 multiplied by the first 5 numbers, and so these are the first 5 multiples. Let us write them together. 5, 10, 15, 20 and 25. So these are the first 5 multiples of 5. Then we have to find the first 5 multiples of 8. Again we can directly write the table of 8 or we can show the multiplication statements in this way. 8 ones are 8, 8 twos are 16, 8 threes are 24, then we have 8 fours are 32, then 8 fives are 40. So we have the first 5 multiples of 8 as 8, 16, 24, 32 and 40. In this way. Similarly, if you are asked first 6 multiples or first 10 multiples, you can simply write the table up to 6 or 10, whatever has been asked. Then we have first 5 multiples of 9. Let us write them directly. Simply the table of 9 is enough for us. 9 ones are 9, 9 twos are 18, 9 threes are 27, 9 fours are 36, 9 5s are 45. These are the first 5 multiples of 9. We have simply written the table of 9. Then we have the next question. Match the items in column 1 with the items in column 2. Here we have some numbers and here we have the factors and multiples. Whatever has been given, we will see one by one, and we have to match both the columns. The first number is 35. Let us try to analyze each part separately. Is 35 a multiple of 8? Clearly not. 35 is not present in the table of 8. We know 8 4s is 32 and 8 5s is 40. 35 is not there. So this does not match. Multiple of 7. Is 35 a multiple of 7? Is it present in the table of 7? Yes. 7 5s are 35. And so 35 is a multiple of 7. In this way we can match these two. Then 15. 15, is it a multiple of 8? No, we know 8 2s are 16. It's not 15. So 15 is not a multiple of 8. Then is 15 a multiple of 70? We know that multiples are greater than the number, and here 15 is less than 70. So it cannot be a multiple of 70. Then is 15 a factor of 30? What do you mean by a factor? A number which divides the given number completely, exactly. Will 15 divide 30 completely? It will if 30 comes in the table of 15, and we know 15 2s is 30. So yes, 15 is a factor of 30, because if we divide 30 by 15, it's 15 2s are 30 and we are getting a remainder 0. So yes, 15 is a factor of 30. Then we come on to 16. Again we start from the first one. Is 16 a multiple of 8? Is 16 a multiple of 8? Will you get 16 in the table of 8? Yes, 8 2s are 16, and so 16 is a multiple of 8. Yes. Then 20. Is 20 a multiple of 70? Again 20 is less than 70, so it will not be a multiple. It cannot be a multiple, because multiples are either equal to the given number or greater than it, and it is less than 70. So this is cancelled. Is 20 a factor of 50? Is 20 dividing 50 completely? Is 50 present there in the table of 20? Obviously not. We know 22s is 40 and 23s is 60. 50 is not there. So it's not a factor of 50. Then 20, factor of 20. Yes, every number is a factor of itself, and so 20 is a factor of 20. These two will match together. Then we have 25. Is 25 a multiple of 70? Again it is less than 70. It cannot be a multiple of 70. Then is 25 a factor of 50? Yes, it will be if 25 divides 50 completely, or if 50 is present there in the table of 25, and we know that 25 2s is 50, and so this is a factor of 50, and yes, these two will match properly. So in this way we have matched, and this one will be left out. Okay. Then we have find all the multiples of 9 up to 100. Here we have to find the multiples of 9 up to 100, means less than 100 till 100. And so we will start finding the multiples from the first one by multiplying 9 by the number 1 itself. And so the first multiple will be 9. 9 1s are 9. The second multiple we will get by multiplying 9 and 2. 9 2s are 18. This is the second multiple. Then how we will get the third multiple? 9 3s are 27. Simply write the table. Fourth multiple, 9 4s are 36. Fifth multiple, 9 5s are 45. Then sixth multiple, 9 6 are 54. Yes, very good. We are doing very well. Then the seventh multiple, 9 sevens are 63. Then the next one, 9 eights are 72. Yes. The next multiple, 9 nines are 81. All these are less than 100, remember that. Then 9 tens are it's 90, again less than 100. Then 9 elevens are is 99. Now we have reached very much close to 100. And then if we write the next multiple, it will be 9 12s are 108. If we write it here, 108. Now is this less than 100, up to 100? No, it has crossed 100. So it will not come here in the answer. We have the multiples of 9 up to 100 till 99. It's very much close to 100. So these are all the multiples of 9 up to 100. I hope this exercise is very much clear to you. You can write down your own numbers and try to find out their multiples and factors. We will soon meet in our next class with prime and composite numbers. Till then, goodbye.